Hello, welcome to this session in which we will be talking about bearings, and in particular we'll be focusing on how to tackle bearing problems. Students usually find difficulties in solving questions involving bearings, and it is important to note that for you to be able to solve questions on bearings, there are certain basic concepts of trigonometry that you need to know. We have first a right-angled triangle, and if I have an angle there, ABC, then by Pythagoras theorem I can be talking of AB squared plus BC squared equals AC squared. At some point in the solving of bearings, you will be required to use Pythagoras theorem, as well as use trigonometric ratios in solving some situations. So you need to use SOHCAHTOA if at all you are dealing with a right angled triangle. There is also the need to use the cosine rule as well as the sine rule, where the triangle is not right angled. You have a case where a triangle will come out and is not right angled, then you would be required to use the sine and cosine rules. If I have A, B, C, then this is side C, and here side A, here side B. The cosine rule, A squared equals B squared plus C squared minus 2 BC, then cos A. I could also need to use the sine rule, sine A over side A equals sine B over side B equals sine C over side C at various situations. There are also situations where you would need to use the notion of parallel lines. When two lines are parallel and there is a transversal, in particular alternate angles, angle A is alternate to angle B, and they are supposed to be equal. A equals B. You would also need to use that. Now, when you read a bearing problem, they will be talking about some particle moving from a point A to a point B on a particular bearing, and possibly onto another point C, still on another bearing. And you will be required to do some calculations, be it of bearings or distances. And the setup that always ends up coming out is a triangle. The triangle could be right angled or otherwise. It is just for you to investigate. If I take, for instance, a particle that leaves point A on a bearing of 0-60 degrees and then moves to point B. I move to point B from where it then moves to C on a bearing of 120 degrees. And you can be required to do some calculations. The first thing is to draw the appropriate diagram, and you note how I'm going to interpret this diagram, because the diagram usually is where people have problems solving. If I start from point A, I would start by drawing the north direction, because bearings are measured from the north clockwise. If I am to be on a bearing of 0-60, then I can put something like this, and this will be 60 degrees. At B, the particle then moves on another bearing of 120 to reach C. So in this case, I would indicate again my north before I can do the motion from B to C. That bearing is good to indicate now the 4 cardinal points to really know where the angle will lie. If this is the north, then my bearing starts from that north clockwise, and I wouldn't be indicating 120 degrees as specified. It wouldn't help me in the calculation. My angle of interest is this acute angle that is carved out. So I know that this is 120 degrees and this is 90 degrees. So the rest of the angle should be 30 degrees. So I would arrive here at C, and then the question can now start asking me certain calculations. I first have to connect the original point with the final point to obtain a triangle. They might say that this is 7 kilometers, it moved this way, and maybe 8 kilometers to arrive this way. So if there is 90 and then 30, it means that this being a straight line, this angle should be 60 degrees. We already have 30 here, and this being a right angle, this should be 60. Then by alternate angles, remember this line is parallel to this one, so by alternate angles this 60 degrees would also appear here. 60 degrees. In the end now, I will be getting a total angle there of 120 degrees, and the questions that could come, they will ask you to find the distance of the particle from the original position. So they'll be looking for distance AC. They can also ask bearing of A from C, even bearing of C from A. Those are the possible questions that could follow that diagram. Now in the case of the distance AC, it is simple. If you come and analyze this angle here and it is 90, then you are dealing with a right angle triangle, and you can use Pythagoras theorem simply to obtain AC. But then the angle not being 90 degrees, we are bound to use the cosine rule. I know two sides and there is the other side I need to find. The angle between the two sides having been provided, I can then use the cosine rule. So I'll be talking of AC squared being equal to 7 squared plus 8 squared minus 2 into 7 into 8, the cosine of that angle. And from there I can calculate my AC. For the bearing of A from C, I have to go to C. They say from C, so I go to C because they've said from. I go there, and then I indicate my north direction, and then carve out the angle from the north till the line joining C and A. That is the angle that gives me, or that is the angle which represents the bearing of A from C. In order to get this angle, I would need to find this angle and this other angle, can call it alpha, so that I can now subtract the sum of the two from 360. That will be the easiest way to do it in order to get that bearing. If you complete that triangle up there, you see that is right angle. This is 30, then obviously alpha is 60 degrees. So the main task now is to get angle theta. And to find theta, then we can use the sine rule. AC having been found, suppose AC is x, the value I have here, I would come now and I will first find sine theta over the side opposite the angle, which is 7, should be equal to sine 120 over the side opposite that angle, which is x. When I cross multiply, I'll be able to solve for theta, x having been found up here. This is AC actually. The distance there is AC. So I cross multiply and solve for theta, and that is how I will get that angle. And so the bearing now should be equal to 360 degrees minus theta minus alpha. For the bearing of C from A, I go to A, and from the north it is that angle up to the line again, joining A and C. That will be the bearing of C from A. But then this other part, this other angle up is 60 degrees, so this other one I can designate it as beta, and again I can use the sine rule to get beta. I can be talking of sine beta over the side opposite that angle, which is 8, should be equal to sine 120 over the angle opposite, which is AC, obtained up. Cross multiply and solve for B, and then that bearing would be 60 degrees plus beta. Solve for beta.